Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we will continue our lecture for clustering topic. So as you know, okay, clustering is a process of grouping our data based on similarity. Okay, so the example of clustering application we can apply in marketing, land use, insurance, urban planning, and seismology. So for marketing, clustering can help marketers discover distinct groups in their customer bases and then use this knowledge to develop targeted marketing programs. For land use, to identify area of similar land use in Earth observation database. So for insurance, we can identify groups of motor insurance policyholders with a high average claim cost. So walaupun nampak macam clustering ni satu proses yang simple tapi dia tetap banyak kegunaannya dalam pelbagai sektor lah. Okay, so kita lihat macam mana nak dapatkan cluster yang baik. So a good clustering will produce cluster with high intra-class similarity and low inter-class similarity. Okay, apa maksud intra-class ni? Maksudnya kalau dalam kelas yang sama, dalam group yang sama, dia punya similarity between each point tu adalah tinggi. Tetapi kalau untuk yang berbeza group, maksudnya kluster pertama dengan kluster kedua, kita nak apa dia punya similarity tu rendah. Maksudnya perbezaan dia tu yang lebih ketara lah. Okay. Precise definition of clustering quality is difficult because of application dependent and ultimately subjective. So the quality of a clustering method depends on the similarity measure used by the method and its ability to discover some or all of the hidden patterns. So this similarity metric expressed in terms of distance function. So the definition of distance function are usually rather different for nominal, binary, ordinal, and numeric attributes. Okay, kalau awak ingat semula our last lecture before the test, okay, similarity measure yang kita dah tengok ialah Euclidean distance. Okay, tapi sebenarnya ada banyak lagi pilihan untuk distance measure depending on what kind of data that you use. Okay, so for example, we have Manhattan distance, Minkowski distance, Jacob distance, and then cosine distance. Okay, dan pemilihan ini adalah berdasarkan data. Sama ada nominal, binary, ordinal, and numeric attributes. Okay, so bila kita gunakan distance measure yang berbeza, kita punya cluster pun akan, yang kita dapat juga mungkin akan berbeza lah. Okay, kualiti dia adalah berbeza antara satu dengan yang lain. So, similarity measure ni adalah benda yang kita akan tengok dan pada hari ini. Okay. Okay, this is the distance matrix for numeric attributes. Okay, if you see that your data consists of numeric attributes, so we can use Minkowski distance, Manhattan distance, and Euclidean distance. And these are the formula for each of the distance. Okay. Okay, for binary attribute, symmetric binary attributes, both 0 and 1 are equally important. So asymmetric binary attributes, 0 and 1 are not equally important. So this is the contingency table for binary attributes. So distance measure for symmetric binary attribute is Dij is equal to BC over A plus B plus C plus D. For distance measure for asymmetric binary attributes is BC, okay, B plus C over A plus B plus C. Okay, this is for binary attributes. Okay, if your data consists of nominal and ordinal attributes, okay, we can use simple matching. Okay, uh, P minus M over P, where M is the matching nominal attributes, P is the total nominal attributes. So use a binary attribute for each value of a nominal attribute. So for ordinal attributes, replace attribute values with numeric values 1, 2, 3 and treat them as numerical attributes. Okay, sebenarnya bila kita ada data ni, kita kena kreatif dalam orang kata pengurusan data kita. Okay, kalau sekalipun data kita tu adalah ordinal ataupun nominal, sebenarnya kita boleh buat replacement dalam kita punya data tu dengan menukarkannya dalam bentuk numeric attributes. So bila data kita dalam numeric attributes, pemilihan untuk similarity measures pun lebih wide lah, lebih banyak. Okay. Ini boleh skip. Okay, major clustering approach. Okay, kalau awak ingat balik hari tu, kita dah tengok K-means. Okay, K-means tu yang paling popular antara banyak-banyak cluster method. Dan K-means juga applies partitioning method. Okay, so partitioning construct various partition and then evaluate them by criterion. So a division data object into non-overlapping subset cluster that each data object is in exactly one subset. So for hierarchical, create a hierarchical decomposition of the set object using some criterion. So a set of nested cluster organized as a hierarchical tree. Then we have density base, okay, and then graph based. So density based guided by connectivity and density function, while graph based is adapt to the characteristic of the data set to find the natural clusters. Okay, so hari tu kita dah tengok partitioning method ni sebenarnya. So K-means and K-means. So kita tak cover K-means, kita hanya cover K-means clustering sahaja. So kalau awak ingat balik lah, K-means hari tu prosesnya kita kena decide number of K that kita nak buat berapa cluster kita, and then kita punya centroid, and then the process evaluating calculation of distance measure and assign based on the closest distance measure, and then kita update kita punya centroid based on the mean values, and then the process continue until no change between the new and the old cluster means. Okay. Okay, K-means clustering example. Show two iteration of K-means clustering algorithm for following data points. Assume K is equal to 2 and initial cluster means are 1, 1 and 2, 3. This is the centroid. Okay, kalau awak tengok 1, 1 and 2, 3 ni adalah dalam points tu sendirilah. Okay, kita akan pilih centroid itu berdasarkan kita punya point sendiri. So give cluster means and contents of cluster after each iteration and use Manhattan distance metric. So untuk contoh ni kita guna Manhattan distance Metrik. Kalau awak tengok tadi dekat atas. Okay, this is the formula of Manhattan distance. X minus x1 minus xj1 xi2 minus xj2 xip minus xjp. Okay, so okay, this is the distance. Okay, right. This is the distance. For the first iteration, you can see that this is the distance of every point. Okay, so we find that, okay, in cluster 1 we have 0, 2, 1, 1 and 2, 0. Okay, itu adalah points. Okay, so saya turunkanlah kat sini bagi nampak. 1, 3, 2, 3, 4, 4, 6, 5, 6. Okay, bila awak dah dapat kenal pasti dalam kluster 1 dan kluster 2 tu, apa dia punya, apa orang kata, point yang berada di dalam itu. So, you have to update the centroid. Okay, so kita dah dapat centroid baru. So, macam mana nak dapatkan nilai centroid yang baru tu? Okay, you can see that we have 3 points for cluster 1. Okay, so kita tambahkan untuk dia punya X. Okay, 0 plus 1 plus 2 divide by 3. Why divide by 3? Because we have 3 points. So, bila nak cari min, divide by 3 jugalah. So, we have 1. So, for Y, we have 2 plus 1, 2 plus 1 plus 0 divide by 3. So, 1, 1. Okay, sama juga dengan kluster yang kedua. Okay, this is x1, x1. So, for x2 is 1 plus 2, 1 plus 2 plus 4 plus 5 divided by 4. 12 divided by 4 is 3. And then for y2 is 3, 3, 4, 6. 3, 3, 4, 6 divided by 4 is equal to 4. So, dapatlah macam ni. So, the update. Okay, this one is for first iteration. This is the second iteration. Okay, so bila dah dapat apa yang baru tu, kita cari sekali lagi distance. Okay, cari sekali lagi distance dan kita dapatlah the new points in the cluster. Okay, so sebab soalan hanya minta 2 kali iteration, so kita stop. Kita stop. So this is the answer. So tolong okay, you must very understand how the process of k-means clustering if we do it manually. Okay, so bila kira macam mana nak guna the distance formula and then how to update the centroid. So you have to very understand and orang kata mahir lah untuk buat pengiraan bagi proses k-means clustering ini. Okay. So next, sebenarnya kita nak tengok hierarchical clustering. Kalau partitioning clustering, dia non-overlapping. But hierarchical clustering ni lain, dia boleh nested. So, hierarchical clustering produce a set of nested cluster organized as a hierarchical tree. Okay, this is the example. So, it can be visualized as a dendrogram. This is dendrogram. Okay, a tree-like diagram that records the sequences of mergers or split. So, hierarchical ni ada dua jenis. Satu dia merge. Okay, satu lagi dia split. Okay, do not have to assume any particular number of clusters. Any desired number of clusters can be obtained by cutting the dendrogram at the proper level. Okay, apa maksud point di sini ialah kalau tengok dia interconnected to each other. So kalau kita nak potong, okay, dia kata cutting the dendrogram. Maksudnya kalau dekat sini, kalau kita potong, kalau saya potong dekat 0.15 ni, okay, kita akan nampak ada berapa cluster di situ. Okay, bila kita potong ada 1, 2, 3, 4. Okay. Kalau kita potong ke bawah lagi, ada berapa? Macam itulah. Tu maksudnya number of desired cluster tu kita depends on kat mana kita nak lakukan cutting dalam proses dalam tajuk hierarchical clustering ni. Okay, kita cutting dendrogram tu. Okay. This one is nested cluster. This one is dendrogram. So, this is the example of hierarchical clustering. Okay. A dendrogram shows how the clusters are merged hierarchically. So, decompose data object into several levels of nested partitioning. Tree or clusters are called as dendrogram. So, a clustering data of the object is obtained by the cutting dendrogram at the desired level. So, then each connect component forms of cluster. So, two main types of hierarchical clustering, we have agglomerative and divisive. Agglomerative is bottom up. So it starts with the points as individual cluster. At each step, it merges the closest pair of clusters until only one cluster or K cluster left. Okay, divisive is called as top-down. It starts with one all-inclusive cluster. At each step, split a cluster until each cluster contains a point and there are K cluster. Okay. So, kalau kita tengok kat sini, hierarchical clustering, it uses distance metric as clustering criteria. So, this method does not require number of clusters K as input, but needs a termination condition. Okay. So, kalau kita tengok kat sini, awak boleh nampak, this is step 0, 1, 2, 3, 4. This is for agglomerative part. Okay, it is bottom up. Okay, and then the bahagian bawah. Okay, we have step 4, step 3, step 2, step 1, and step 0. It is divisive or top down. Okay, macam mana nak fahamkan ni? Okay, untuk agglomerative, tadi dia ada beritahu kepada kamu bahawa agglomerative is bottom up. Bottom up and it start with point as an individual cluster. So, kalau kita tengok kat sini, okay, kita ada 1, 2, 3, 4, 5. We have 5 points. Okay, 4 points. And then, each point is as a cluster. Okay, for agglomerative, it will merge. Okay, so daripada 5 cluster tadi, kita tengok step 1. Step 1 is step 1 the points A and B merge. And then step 2, points D and E merge. Step 3, C, D, E merge. Okay. And then step 4, A, B, C, D, E merge. And the final cluster only 1. But then for for divisive, okay, it starts with only one cluster, and in the cluster all points are all together. Okay, so you can see only one cluster A, B, C, D, E in that cluster, and then it divides. Okay, in step 1, new cluster forms, and in it is C, D, E. Then it divide again into new cluster CDE. Okay, DE dalam cluster yang sama, C dalam satu cluster yang lain. Okay, sampailah, okay, sampai ada final step, all the points becomes cluster. Okay, and all the points are in own cluster. Okay, tapi boleh jadi sebenarnya final step tu ada beberapa cluster dan bukanlah setiap point tu berada dalam satu cluster sendirian. Okay, ini hanyalah gambaran macam mana proses aglomeratif dan divisive itu. So, agglomerative, it produces tree of cluster. Initially, each object is a cluster. So, recursively merge nodes that have least dissimilarity. So, the merging process is merge the node that have least dissimilarity. Maksudnya dia ada similarity lah, least dissimilarity, but it have high similarity. So, criteria: mean distance, max distance, average distance, center distance. And then eventually all nodes belong to the same cluster. Okay, this is the process. Okay, for divisive, it is an inverse order of agglomerative. It starts with root cluster containing all objects, recursively divide into subcluster. Eventually, each cluster contains a single object. Okay, you can see. Okay, initially, okay, the first step we have two cluster and it divide again until kita tengok makin lama makin banyak dia punya cluster. So this is for divisive. So agglomerative is more popular hierarchical clustering technique. So the basic algorithm is more straightforward. It computes the proximity matrix. Let each data point be a cluster, and then it's repeat. It merge two closest cluster. Update the proximity matrix until only one single cluster remains. So the key operation is the computation of the proximity of two clusters. So different approaches to defining the distance between clusters distinguish the different algorithm. Okay, you can see starting situation start with cluster of individual points and proximity matrix. Okay, so this is how the proximity matrix looks like. Okay, and then after some merging step, we have some cluster. Okay, so tadi mula-mula kita hanya ada points. Okay, then kita merge. And then we want to merge two closest clusters, C2 and C5, and update the proximity matrix. Okay, so this is how the dendrogram looks like. Okay, after the merging, the question is how do we update the proximity matrix? And then how to define the intercluster similarity. Okay, so for agglomerative, we have mean or single linkage. Okay, So single linkage is nearest neighbor, and then we have max, group average, and distance between centroid. So how? Okay, this is kalau kita gunakan single linkage, okay, untuk intercluster similarity ni, okay, kalau single linkage, it means that dia akan ambil yang the closest point. Tapi kalau max, okay, kalau max, dia akan guna furthest neighbor. Okay, max link, okay, max distance juga dipanggil sebagai complete linkage. Okay, and then kalau gunakan group average, it means that dia akan cari distance untuk setiap points and then find the average. And then how to next, if we use the distance between centroid, it means that we have to find the centroid for each of the cluster. So let's see the linkage function that we have seen at the above at the previous slide. So for linkage function, we know how to measure distance between two objects by defining distance between an object and a cluster, or defining distance between two clusters is not obvious. So we have single linkage. Okay, single linkage, the distance between two clusters is determined by the distance of the two objects in the different cluster. So it uses the minimum distance. But for the complete linkage or max study, okay, so you have to be very careful. Okay, sebab ada dua nama. Satu kita guna mean ataupun mean distance atau nama dia ialah single linkage. Kalau max distance namanya ialah complete linkage. So for complete linkage, the distance between clusters are determined by the greatest distance between any two objects in a different cluster. For group average, is the distance between two clusters is calculated as the average distance between all pairs of objects in the two different clusters. Okay, SL single linkage consider only a single pair of data points. If this pair is close enough, then action is taken. So SL can form a chain by combining relative apart data points. So SL often violates the compactness property of a cluster. So SL can produce cluster with large diameters. Okay, so see, this is the example for linkage function. If we use the average linkage, so you can see that this is how the dendrogram looks like. This is for complete linkage and this is the single linkage. Okay, cluster similarity. Okay, mean linkage or single linkage. Similarity of two cluster is based of two more similar or closest point in the different cluster. Okay, determined by one pair of points by one link of the proximity graph. Okay, this is the strength of single linkage. Kita dapati, okay, bila kita gunakan single linkage, dia dapat orang kata bezakan betul-betul cluster yang diperoleh. Okay, tetapi untuk single linkage ni, dia very sensitive. It is very sensitive to noise and outliers. Okay, kenapa dia begitu? Okay, sebab kalau kita tengok balik tadi, single linkage ni, dia menggunakan the closest distance. Boleh jadi sebenarnya the closest one itu sebenarnya hanyalah outliers ataupun noise dalam data. Okay, so single linkage ini sensitif terhadap data yang mempunyai outliers lah. Okay, untuk max ataupun complete linkage, Similarity of two clusters is based on the two least similar distant point in the different cluster. Okay, so determined by all pairs of points in the two cluster. So kalau kita tengok kat sini, perbezaan dia ialah, okay, tadi, okay, okay, dia kata kan two more similar. Kalau ini kan two more similar. Okay, awak tengok. Okay, permulaan dia, okay, dia buat, okay, untuk jadikan satu cluster, okay, similarity of two clusters is based on two more similar in the different cluster. Maksudnya kat sini, sebenarnya distance between point 2 and 3 ni sangat dekat. Tapi dia jadikan sebagai cluster yang berbeza. Itu untuk single linkage. Tetapi, okay, sebab tu dia punya perbezaan dendrogram ni. Kalau kita tengok, kalau kita gunakan max, okay, kita gunakan max link ataupun complete linkage, kita akan untuk cluster tu, dia akan cari yang the most distant ataupun the very least similar. So, dekat sini, okay, dia akan terpisah. Okay, permulaan dia. Awak tengok 3, 6 and 2, 5 ni, dia akan, mana yang paling yang jauh itu akan jadi the starting of the cluster. Okay, so boleh bezakan balik nanti. Okay, boleh tengok macam mana proses ni sebenarnya berlaku. Nanti kita akan cuba buat latihan nak nampakkan betul-betul perbezaan single linkage dengan complete linkage ni, and then macam mana nak buat dia punya dendrogram. So don't worry. Okay. And then kalau tadi bila guna single linkage tadi, dia sensitif kepada noise. Tetapi kalau kita gunakan max, okay, max distance ataupun complete linkage, it less susceptible to noise and outliers. Sebab apa? Sebab kita memang akan cari distance yang jauh untuk jadikan dia kita nak jadikan dia different cluster. So next limitation of max cluster is it tries to break large cluster. It is biased toward a globular cluster. Okay, next we have group average. So proximity of two cluster is the average of pairwise proximity between points in the two cluster, and then need to use average connectivity for scalability since total proximity favors large cluster. Okay. Okay, density-based clustering method. Clustering based on density or local cluster criterion, such as density connected points. Okay, major features of density-based clustering method is discover cluster of arbitrary shape. It can handle noise, one scan, and need density parameter as termination condition. Okay, so you can read by yourself for density-based clustering algorithm. Okay, so we will continue this topic on the next lecture. So we will continue about how to evaluate our cluster. Okay, so in the next lecture, you have to bring along your laptop because we will use Python, okay, for our hands-on class for clustering and also classification. Okay, so don't forget, and I wish you have a good day. See you next week. Thank you.